Okay, don't draw what I'm drawing now. So let's look what will happen. When we incident light, and this time we have an voltage supply also. So here we are going to draw the variation between the voltage and the photo current. Initially, let's start with short circuiting this battery. When I short circuit this battery, is there any voltage supply? There is no voltage supply, or you can just remove this battery. But you have removed this battery. The battery is no more. Here you don't have a battery. And when there is no battery, and you're shining light, or you're radiating the electromagnetic radiation onto this cathode, will you have a current? Yes, if the energy of a photon is sufficient to release photoelectrons, then there will be a photocurrent. Therefore, even though the supply voltage is zero, we have a certain current. But when we increase the voltage supply, when we slightly increase the voltage supply, you can see that current slightly increases, and after that it becomes constant. It remains constant. Okay, what is the reason for this slight increase? The reason is initially when you shine or when you radiate this electromagnetic radiation onto this cathode, when you don't have this supply, this anode is neutral. Okay, it is not plus or it is not minus. It is not plus or minus. It is neutral. When it is neutral, this electron necessarily is not captured by the anode. But when we provide an external supply, now this becomes slightly positive. Therefore, more electron is captured by this anode. And when the supply voltage is high, it is highly positive. Therefore, all the electrons are captured. And after that, the current remains constant because the current, this photocurrent, only depends on the intensity of radiation. Is that idea clear? Why this current is increasing? So here we discussed 3 points. First one, why we have a current although voltage is zero. Second, why it is increasing. Third, why is it constant? Okay, you must understand those 3 points. And after that, we reverse the terminals. When we reverse the terminals, so we reverse the terminals. When we reverse the terminal, let's see what will happen. To understand that, now this is the cathode. This is the cathode. And here we have the anode. We connect the battery from the, the positive side of the battery is connected to the cathode and the negative side is connected to anode. And now we radiate electromagnetic radiation towards the cathode. Therefore, the electrons are released from the cathode and moves towards the anode. But due to this external voltage, in which direction do we have the electric field? The electric field is from cathode to anode. This is the direction of electric field. And electrons, do they tend to move along the electric field or opposite the electric field? They tend to move opposite the electric field, right? They want to move opposite the electric field. So what can you tell about the electrons? They are feeling an opposition, right? They're feeling an opposition. They are not easily moving as before. And these electrons, we don't have only single electron, right? We have a lot of electrons, and those electrons, they have different kinetic energies. Everyone doesn't have the same kinetic energy. They have different kinetic energies. So electron with less kinetic energy, they are not able to spend the energy and reach the anode. So this electron is also not able to reach the anode. Only a few electrons will be able to reach the anode. Therefore, when we reverse the terminal, the current reduces. The current reduces. At a certain instant, when we increase the voltage, when we increase this reverse voltage, it is having sufficient energy to oppose this electron with the maximum kinetic energy. So the current becomes zero. The current becomes zero. And this voltage over here, we call the stopping voltage Vs. Is that idea clear? So you must understand why current reduces and why it is not suddenly dropping to zero. When we reverse the voltage, why it is not suddenly dropping to zero, but why it's going in a curve like this. Because all the electrons are not having the same energy. All the electrons are not having the same energy. The electrons with less energy will stop previously. Okay. Is the idea clear? Initially, the voltage supply is short circuit and light is incident on the cathode. So look, when it is short circuit, there is no external supply, but still we have a reading. And when we connect the voltage supply, the voltage is increased using the sliding key. The photocurrent slightly increases and remains constant. When the terminal of the battery is reversed and applied voltage is increased, the photoelectric current reduces. We discussed the reason. For a certain applied voltage, the photocurrent becomes zero. This voltage is known as the stopping voltage, Vs. After that, the IV characteristic of photoelectric emission is as follows. And below that, you have to draw this graph. First, note these points and let me know. Once you have completed, let me know. Shama, we discussed about stopping voltage also. Can you copy that too? So here we have discussed the minimum voltage required to reduce the photocurrent to zero is stopping voltage. The terminal of the battery is reversed. So we discussed this point. This is also discussed. Yeah, we have discussed all these points. Saja, have you done the first part? Uh, before copying that, we have to draw this graph, right? Draw this graph. Done. Copy this. Copying the notes during the class time is easy, right? When doing it later, it becomes another load. That's why I'm asking you all to note it down during class itself, although note is given earlier. Here, for this, we can get an equation, work done, that is equal to the change of kinetic energy, right? We have an equation. So this work done, we can write it as E into charge into potential difference. Now, charge is an electron. The potential difference is the stopping voltage Vs. This is equal to the kinetic energy maximum minus 0. Why? Initially, it starts with high kinetic energy, the maximum kinetic energy. Finally, the kinetic energy is 0. So, we have the stopping voltage EVS is equal kinetic energy maximum. And we can write EVS is equal half mass of electron into the maximum velocity squared. Once you have completed, let's stop for today and let's discuss the remaining in next class. So next class we can finish up to X-rays. So if we finish X-rays, radioactivity is the last part. Again, there's a lot of notes, but a few theory. You need more time to write than more time to understand. That's the problem, right, in this part. Too much to write.